So today we will talk about logarithm. So what is a logarithm? It's the exponent x to give to the base b to get the number y in the expression b exponent x is equal to y. So what you have to remember is that a logarithm is an exponent. So now which exponent is it? It's the exponent I need to give to the base b to get y. We're going to show a couple of examples so you understand what we're talking about. Now you have to see that if you have a base exponent x, this here we're going to talk about when it's greater than 0. So only when it's positive. Otherwise, it wouldn't make sense that it would change from positive to negative depending on the exponent. Um, Now the way we're going to write it like this. Log of y in base b is equal to x. So for example, if I give you 3 exponent 2 is equal to 9, and I ask you to write that in a logarithmic form, then you know that a log is the exponent. So the log is going to be equal to the exponent. Now the base of the log is going to be the base of your expression here. So the base is 3, and the number that's left to place is 9 here. So the log of 9 in base 3 is 2. That means the exponent I need to give to 3 to get 9 is 2. When we talk about log, just regular log, it's always in base 10. So we don't have to write base 10. If you look on your calculator, you will see log, and so you have to know that it is in base 10. So for example, log base 10 of 100, we would write it like this, log of 100. And you can try to see if it works on your calculator. What is the exponent I need to give to 10 to get 100? So if you try it on your calculator, you should get 2. So try to see if you can find it on your calculator. Another one we can try is, hold on, I'm gonna get some room here. Log base 2 of 16, or log 16 in base 2. That is equal to what? It is the, so you don't need your calculator for that one. It's the exponent you need to give to 2 to get 16. So 2 exponent what will give you 16. So I suggest you count. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So as I was counting, I would use my finger to count how many 2's I use. I use 4. So this is equal to 4. Now, as you can imagine, on your calculator, it's not going to always be a whole number. So if you had to do that on your calculator, I told you that on your calculator, it's always base 10, right? It's always base 10. So what you would have to do if you wanted to do that on your calculator, you would do log of 16 over log of 2. It is called the change of base rule. We're going to learn more rules later, but this one is the basic one. Change of base, because see, now we had a base 2 and we want to put it in base 10 so we can use our calculator. Okay, so you can try on your calculator to do log 16 over log 2 and you should get 4. That's a good way to practice for you on your calculator. Now if you look carefully on your calculator, you will see that there's also in the second part of the log, there's a button that's called ln. So this is the natural log, and this is a log in base e. Now, what is e? E, if you try on your calculator, e exponent 1, it is a constant. Did you find e on your calculator? So if you do e exponent 1, you're going to get something around 2.71. E is a constant we're going to use for scientific problems. We'll use it later. So if I asked you to find, let's say, you will see in your book, they write it in small letters. So this is really ln on your calculator. So if you have to find ln of 10, for example, it is the same as log base e of 10. And you can just plug that onto your calculator. Okay, so this is just for you to remember what it means. If you plug that into your calculator, you should get something approximately 2.3. So you have to remember that it's always better to keep the form that gives you all the answers. So this would be the answer because 2.3 is approximate. So we don't necessarily want approximate answers. All right, so let's practice with some values. So if you have, remember, anything exponent 0 is equal to 1. So if I ask you to change this into the log form, you would get, so we know log is equal to the exponent, and the base is the same as the base of your exponent. And so what's the exponent? We need to give the 5 to get 1. So you would write it like this. Now I suggest you pause the video at this point and try to fill the rest. And when you're done, you can come back to check the answers. Okay, so if I had to do this one, I would do log base b of 1 is equal to 0. This one would be log base 8 of 1/8 is equal to -1. It means what is the exponent I need to give to 8 to get to 1/8? And remember, when you have negative exponent, if you have, for example, 5 exponent -2, it would be 1/5 exponent 2. So remember, negative exponent. The next one is, what if you have square root of 9 is equal to 3? You have to remember square root is the same as exponent 1/2. So it would be log in base 9 of 3 is equal to 1/2. So also you have to remember that square root is the same as exponent here 1/2. Exponent 1/2. Okay, and the last one was cubic root. So when you see cubic root, you have to change it into the exponent form. And so you know the log in base 8 of 2 is equal to the exponent 1/3. So again, you have to remember that cubic root is the same as exponent 1/3. Okay, so that's just reviewing what we did with radicals earlier in chapter 1. Now, if you have to solve this, for example, there's two different ways to solve it. The first one on the left, you know that 2 exponent x is 8. You can turn it into base 2. And remember, we already practiced that I don't know if you did it in the book or not, but how do you change 8 in base 2? So you have to think 2 times 2 is 4 times 2 is 8. So you know that 2 exponent x is equal to 2 exponent 3. Therefore, you can assume that the exponents are the same. So we can assume that x is equal to 3. It's not that we're simplifying the 2's, right? It's just that we can assume that the exponent have to be the same because the bases are the same. Now this works because we know that they have the same base. You can also, if you wanted to, you could also have said, I'm going to turn this into log because I know the log in base 2 of 8 is the exponent, right? And then if you wanted to do that on your calculator, you have to change the base. So it would be log of 8 over log of 2. So I suggest you try also to do it this way on your calculator to make sure you get the same answer. Because what happens if you have to find 2 exponent x is equal to 9? Well, 9 doesn't have the same base, right? So we cannot turn it into the same base. So this one, we don't have choice. We need to change the form. So we're going to write it in the log form. So log base 2 of 9 is equal to x. If you take your calculator and you calculate, you're going to get log 9 over log 2, right? But if you calculate, it's going to give you approximately 3.0 16999. So which answer is the best? Is it this one or this one? Okay, you know me, I'm gonna ask you for the precise answer. So this is what you would need to answer because this one is approximate. Okay? And if you want to just practice what this means here, it means what's the exponent we need to give to 2 to get 9, which reflect what we have at the beginning. What's the exponent we need to give to 2 to get 9? One more thing. Oh, sorry. Here we can practice to evaluate this logarithm to a single number. So if you look at the first one, log in base 3 of 27. What is the exponent you need to give to 3 to get 27? So 3 times 3 is 9, times 3 is 27. So it would be 3. You shouldn't use your calculator for this one, okay, because you should understand what it means. In question B, we don't see the base here. So when we don't see the base, then you have to know it is 10. So 10 exponent what will give you 100,000. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So your answer should be 5. Here you have 2 exponent 5, exponent what? That's going to give you 4 exponent 25. So you can change the base if you want. This is the same as 2 exponent 2. This is the same as 5 exponent 2. So really, this is the same as 2/5 exponent 2. So that's the kind of reasoning you should do. Show all your work, so that way you're not going to make any mistakes. So this one should be 2. For D, you have 2 exponent what is equal to 1/4. 1/4 is the same as 2/2, and it's at the bottom, so if you bring it back up, it's going to give you this. 2 exponent -2, so therefore you can find that your x is -2. And the last one, ln of e, this is log base e of e. So what is the exponent, right? What is the exponent you need to give to e to get e? Well, e is, by definition, e exponent 1, so therefore this is 1. For the second part, you have to convert them as logarithms, so I suggest you pause the video, try to do it, and then after check your answer. So for this one, log base 11 of 121 is equal to my exponent, because remember, a log is equal to an exponent. For the next one, you have log base, oops, sorry, not base 116, log base 4, because you have to look at what number is at the bottom of your exponent of 116 is equal to your exponent, and your exponent here is -2. Square root of 9, you have to remember, is the same as 9 exponent 1/2, right? So log base 9, because that's at the bottom of your exponent, of 3 is equal to 1/2. And the last one, you have to remember, 8 is the same as 8 exponent 1/3. So log base 8 of 2 is equal to 1/3. Last thing we need to do is to solve. So if you have to solve 10 exponent x is equal to 50, because you're looking for the exponent, you have to think, oh, I'm going to turn this into log, because I know log is equal to my exponent. My base is what's at the bottom of my exponent, and my other number will come here. Now you can take your calculator if you want, because log base 10 is the same as log 50. But if you check on your calculator, it's going to give you something approximate. Okay? So make sure that you keep this as your answer. So I suggest you pause, try the 2 other problems, and then after check to make sure you got it right. So the next one, because you're looking for your x here, and we're not sure how to do that, we can use our calculator, but if we don't want to use our calculator, we can change it to the other form. So my base here is going to be here. My exponent, I know my log is equal to an exponent, so my exponent is x, and I want this to be equal to 25. And I know 25 is the same as 5 exponent 2. So I can figure out that my x has to be equal to 2. And the last one, if you change this into the other form, we're going to have x exponent 2, because x is our base, so x exponent 2 is equal to 49. How do you get rid of a 2 here? Square root on both sides. So x is equal to 7. Now, remember when you square root, it should be plus or minus 7, right? But because we said at the beginning that when we're having log here, the base always have to be positive, x has to be greater than 0, so we cannot take the negative as an answer. So our answer is going to be just x is equal to 7. If you want, you could use your calculator to check what the graph of log of x looks like. But we're going to do that more in detail in the next part. Have fun!